This tutorial will show you how to build an AI podcast generator in Python, step by step. We'll upload a PDF, create embeddings, and use Agentic RAG with an LLM to generate a podcast script. Then, we'll convert the script to speech with an AI text-to-speech model and stitch it into an MP3 file. We'll be using OpenAI and ElevenLabs as the core generative AI tools. OpenAI will help us generate the podcast script, while ElevenLabs will convert it into lifelike audio. For the Python libraries, we'll rely on Llama Index to create the Retrieval-Augmented generation, or RAG agent for processing the document, and PyDub to stitch the audio together. This tutorial is just a template to get you started with AI podcast generation. You could enhance the starter code by adding a more comprehensive prompt, incorporating multiple PDF documents, and tweaking the voices to be more realistic. I've structured this tutorial into 3 sections. First, we'll start with a walkthrough of creating API keys and setting up the initial configuration for the project. Second, I'll show you how to process PDF documents and use AI agents to perform advanced RAG, creating an efficient workflow to generate a podcast script. Finally, I'll guide you through converting the script into a polished audio file, bringing your AI-powered podcast to life. Before we begin, make sure to like, comment, and subscribe to the Deep Charts channel if you find this tutorial useful. Begin by going to platform.openai.com and either create an account or log in if you already have an account. Then go to the dashboard and open the API key page. Click Create New Secret Key on the upper right-hand side of the screen to create your API key. We'll be using the GPT-4o mini model through the API, which is very affordable, as well as the cheapest text embedding model. For reference, preparing this tutorial, which involved several runs of the Agentic RAG, cost me just a few pennies. But if you're concerned about cost, you can set a budget alert and limit in your account settings. Now, go to ElevenLabs.io and click Get Started for free to make an account. The free plan will give you 10 minutes of text-to-speech each month, which is enough to do a few runs of this podcast tutorial. If you get more serious about making AI podcasts either for personal or commercial use, the starter and creator plans are not too expensive. With your account created, you can now go to the API key page in Settings and create an API key. Shifting to a terminal, you'll need to create a new Python environment set at Python version 3.12.8, either through Conda or through a virtual environment. Then install through pip the following packages: Llama Index, LangChain, ElevenLabs, PyDub, and IPyKernel. So we have our API keys and our Python environment set up. We can now open a Jupyter notebook in a code editor and start building the podcast generator. We'll start by importing our libraries and specialized functions, and then saving our API keys for OpenAI and ElevenLabs as objects. Next, we can set some basic configurations, which will connect as arguments in specialized functions later on in the notebook. I've set the podcast length to 3 minutes, added a file path to the PDF document I want discussed, and have set the personas of the podcast hosts. This is also where I've put the voice ID of the specific voice that I want from the ElevenLabs website. We're all set with configuration at this point, and we can start with loading our PDF document and preparing it for Agentic RAG. Let's walk through how we load documents and create a vector store index. For now, we're working with a single PDF file, but the process is designed to handle multiple files if they're added to the uploaded files list. We use Simple Directory Reader to process each file, reading its content with the load data function method and combining all extracted documents into a single list. Next, we configure the OpenAI embedding model, text embedding 3 small, to convert text into numerical vectors that capture its meaning. The API key authenticates our connection to OpenAI, and we save the embedding model in the application settings for reuse. Finally, we build the vector store index using the vector store index class. This organizes the document embeddings into a searchable database, enabling fast and accurate retrieval of semantically similar documents, not just based on keywords, but on the meaning of the text. Now let's break down how the podcast script generation process works. First, we initialize the language model OpenAI's GPT-4o mini by providing the API key. The configuration is saved in the settings to ensure reuse across the application. We then incorporate a document retrieval tool, underpinned by a query engine, to allow for agentic document searching. This query engine efficiently locates relevant content, enabling the tool to quickly access key information for the podcast script. The document retrieval tool empowers the agent to integrate document data into its workflow. This is vital for Agentic RAG because it enables the agent to generate contextually accurate and well-supported outputs by combining retrieval with generative AI. We use a custom prompt template from the LangChain library to direct script generation. This prompt specifies that the language model should create a fluid and conversational script between two interviewers and should maintain consistent personas and tones. To ensure the script is concise and fits the desired podcast length, we include parameters for podcast time length and make an assumption that our hosts speak at an average pace of 150 words per minute. Now, we initialize the agent with OpenAI Agent from tools which combines the query tool for document retrieval and the GPT-4o mini language model that we previously set as the LLM. The query tool enables the agent to iteratively extract document-specific details as needed while it works on the script. Guided by an overarching system prompt, the agent identifies key topics, retrieves relevant information, outlines the podcast, and drafts the script. The script generation prompt that we previously created from LangChain is formatted with personas, podcast length, and word limits, ensuring the output meets our requested specifications. Finally, the AI agent generates the podcast script using the chat method, which we can extract and save as an object called script. I'm going to print the script now, and we can see that there is an interviewer 1 and then interviewer 2 structure. This formatting is vital for the next part of the notebook, where we will convert the script into speech using ElevenLabs. To generate podcast audio, we start by setting the ElevenLabs API key and configuring voice settings. You can check out the API documentation for more information about these customizations. Next, we define a function called generate-audio, which will eventually take each interviewer's specific lines and use the configured voice ID, which we added at the top of the notebook, to generate audio clips. Using the ElevenLabs client generate function, it transforms the text to speech in an MP3 format. To prepare the specific lines, we use a custom function called splitScript. This function breaks the script into segments based on speaker labels, like interviewer 1 and interviewer 2, and organizes the dialogue into a list of tuples, each containing the speaker and their lines. We then save the split segments into an object, which we can then print out. At this point, we can generate and save audio segments. For each segment, we identify the speaker and use their assigned voice ID to create audio clips through the generate audio function, which we just created. The audio output is returned in chunks that are written to MP3 files. They are labeled with the index of the speaker and segment order. So we have our audio segments, and now it's time to put them all together. Using the PyDub library, we load and merge the individual MP3 files into a combined audio track. We save the final file and can listen to the results.
Today, we're diving into a pressing issue: the impact of automation on wage inequality and labor demand. It's fascinating how automation can displace certain workers while benefiting others, isn't it?
Absolutely, and the statistics are striking. For instance, some workers face wage declines of up to 30%, while highly educated individuals can see increases in real wages exceeding 40%.
The full code is up on the Deep Charts Substack page, and if you found this tutorial useful, like, comment, and subscribe to the Deep Charts channel for more videos on how to leverage the latest AI and machine learning tools.